If you like this video, make sure to subscribe to our channel and hit the notification bell icon to get the latest updates.
So today we'll be discussing about a new tool called ABAP Development Tool. In short form, we call it as ADT. So this is an important tool what we use when you start working on ABAP on HANA. Okay, this tool is like what we call this is the place where we need to go if you want to develop or if you want to work on ABAP on HANA related projects. Okay. Right. So we'll just try to understand what this tool is and how it is linked to different systems and how we'll start working on it, right? So if you see whatever the tool we are calling, right, the ABAP development tools, in short, we call it as ADT. So what SAP has done is, or how SAP has built this particular tool is, they have taken the base layer of Eclipse platform. So as you are aware, right? So there is a IDE called Eclipse, which is being mostly used by Java, .NET, so many other set of developers, right? But SAP have taken the particular base platform, Eclipse platform, and they have built few wrapper methods, classes, and they have created new IDEs, right? IDEs are the tools which we use for the front end and the back end development, right? They created two IDEs out of it. So the first IDE, they call it as a SAP HANA Studio. Okay, so if you want to interact with HANA database, if you want to see different tables in HANA database, we generally make use of this HANA Studio. That's one of the tool which we need to understand if you want to start working on ABAP on HANA related projects, right? The second tool, what they have also brought in and what they have built on top of this platform is the ABAP Development Tools, which is ADT. So this is the tool which actually gives us the feasibility to start working on top of HANA layer and build few programs using ABAP programming language. Right? That's the main goal of this ADT tool. So let's say if you want to create a report, a program in the latest versions of NetWeaver, say 7.5, 7.6, right? So in that case, you generally or mostly start using this ADT, because what SAP has done with the introduction of SAP HANA is they have removed few interactions what we generally go and do inside this SAP GUI, right? So they are also increasing developers to get accustomed to this using this particular ADT tool and start doing developments using this particular tool, right? And let's say if you want to create a CDS view, right? So all these things we'll be generally doing inside this ADT only. So we'll be covering these two tools in our upcoming sessions, how to use it, how to configure everything, right? And whatever the tool we are using, and this is being used by a developer, which are, say, whoever an ABAP developer who starts working on this ABAP HANA related projects, right? They generally use these tools. Most of the time they use ADTs, but there will be cases where we also need to have access to HANA Studio just to understand few underlying concepts of the database tables, right? But initially, if you take a classical database, how we generally used to access the tables inside the classical database in a ERP system, we generally log on to that particular system via SAP GUI, and we used to access it, right? So, but when you try to start using SAP HANA database, and if you try to interact with HANA database, so these are the two different steps which we follow. And why SAP has brought in this particular new tool called ADT. So obviously, if someone is bringing or creating or developing a new tool, it definitely needs to address few benefits, and also it also needs to remove few bottlenecks, right? So until unless the new tool is doing these two things, it will not get the response what is expected, right? So we'll see what are the different benefits of Eclipse we'll have. So with the ABAP development tools in Eclipse, we actually get the benefit from the usability perspective. That means the tool is pretty simple and straightforward to use, and it gives us the speed. So when I say speed, if you want to go between two different systems, right? Let's say I'm developing a report and a program, and now I want to access the HANA database tables. Again, I need to go to the other tool or HANA Studio. I need to open it and I want to see the data, right? So what ADT does is it gives us the feasibility of directly interacting our program with HANA database itself, right? So let's say I'll not call that as a different how we try to code a program in the current ERP landscape with the traditional database. But there are few benefits what I can show you when we start doing this programming, right? I can show you all those benefits, what we'll get, right? And this particular development tool improves the developer productivity by better reflecting functionality. It also gives us few code completion aspects, right? It provides us few templates, and it also gives us few auto insertion features as well. So these are all the different add-ons what we'll get in terms of using this ADT, right? So once you have the glimpse of this ADT, you can understand like we'll have different perspectives in it, or we call it as a views, right? So based on your requirement, you can jump to that particular view and you can start directly working on top of your systems itself. Right? And this tool allows us also to connect to multiple ABAP systems, right? And it provides a session failover. That means if the sessions are lost, right? So if we need more sessions, it actually reduces that impact of these lost connections, right? It gives us the feasibility to get connected to multiple ABAP systems in a single ID. It also enables the cross-platform development by integrating this ABAP and non-ABAP development tools. So let's say you have an ADT with you, right? And you started working on an ABAP or a SAP project, right? So now inside your project, you got a reference where you need to create a Java project or a EJB, and out of that EJB, you want to create some web service, right? So that's a non-ABAP development part. So the same thing can also be done within this ADT itself. There is no need for you to go to other platform and try to create it. Let's say if you are using this traditional SAP GUI, right? So what you used to do, so all your ABAP related development you'll be doing inside this GUI. And when you need to create a AGP or a web service, right, you need to go to Eclipse and start doing it. But what this ADT provides us is the ability to do the development of the ABAP as well as non-ABAP development projects as well. That's also a beautiful feature what this particular ADT is providing to us. And these are the different things what will we do. So this is screenshot is just for a reference, just try to understand different things. Anyways, we'll be doing everything hands-on once we get hold of the system. Okay. So the first and foremost thing is, so we will connect to a backend system, right? So let's say I have an Eclipse. This is a brand new tool which I downloaded from SAP. And the first and foremost thing what I need to do is I need to set up a connection, right, with my Eclipse to my backend SAP system. Let's say in our case, it's an ABAP system, right? So once the connection is set up, right, once the connection is set up, we'll be able to access any ABAP repository. So when I say ABAP repository, like let's say if you want to access a package in traditional ERP system, right, we generally go to SCAT, select the package, give the project name, and you should be able to do it, right? So similarly, the same set of activities, we can also do it inside this particular ADT as well, right? So you can create classes, right? And you can create function flows, you can create interfaces, you can create ABAP programs. Along with all these things, you can also able to access the SAP delivered classes, functional modules, BAPs, everything inside this ADT as well. So once you get hold of this ADT, once you understand how this particular ADT works, there is no need for you to go again log in traditional SAP GUI and start using that. Okay, everything you can access it from here itself, right? And here also it gives us the feasibility of making a package as your favorite. That's like if you're using that package very frequently, right? You can make that as a favorite so that you can just open your ADT, just double click and you can directly log into your package. So these are the different things we can do once we have this ADT, right? So how we can edit this code? Let's say here we can saw that, let's say we have a sample program, right? So here HA 400 underscore case underscore study underscore S1. So this is a program what we have inside our package, let's say, right? If I just double click on that, we'll be able to see this particular screen, right? And if you want assistance, like if you want to understand what may be the interface name, what is it method name, right? All those things, if you do a control space, it will give you a hint, like this may be the one which you can use, right? Based on that, you can just select it. So let's say you have a class and you have 4 to 5 methods. You don't know the method names. If you just put a control space, it will show all the methods. So what you can do is you can select based on the method name, and obviously you'll be having an idea of what are the methods does, right? So based on the functionality, you can just select that method and start implementing it. That's the content assist feature it provides, and we can get the content assist feature by using the control space inside the editor, right? And we also have a quick fix feature. Actually, if you do a control+1, it gives us the quick fix feature. So what this quick fix feature does is, so in the screenshot, below screenshot, you can see when I selected this interfaces as ZIF underscore calculator, it is showing me a warning, right? So when I click control+1 on that particular warning, below you can see it gives me a few methods. So the first thing how I can fix it is we can add we can add all those implemented interfaces, right? Because this is an interface. So we did not implement it. That's the reason it is giving a warning. So what we can do as a fix is we can add unimplemented methods. So if you just click on that first method, it will automatically implement those methods inside your class. That's what a quick fix does. It gives recommendations, and also if you just accept those recommendations, it will go and implement it. That's the feature what we'll have. So in the coming sessions, we'll be working on a few objects where we will do this performance improvements and optimization. There, I'll show you how this quick fix helps us. Okay. So this is a good feature what they have brought in, because this one we do not have it inside this traditional GUI screen, right? Quick fix is a good feature. I can show you when we start working on the real-time scenarios. And we can also do the debugging, right? So debugging is a very important part for the developer, because once if something goes wrong in the program what we have written, and if it is not displaying the result what we are expecting, right? We need to in a position to debug that code and resolve it, right? Or to know the root cause, we definitely need to do a debug of our code. So we can also do this debugging of our ABAP code inside this IDE only, ADT. So there is no need for it again go back to your traditional GUI, or you will not get any traditional GUI screen which you used to see when you are working on as a normal ABAP developer, right? So once you start working inside this particular ABAP development tools, everything you'll see it here. So if you see to the right side, you can see the variables list. And if you see at the bottom, right, you can see all the code. And from there on, you can slowly go ahead. And the buttons which are highlighted at the top are the ones which we generally use. F5, F6, F8, right? These are all the different steps what we use. So I just want to reiterate. So I just want to give you a glimpse of how the tool looks like, what are the different things we do, but everything whatever I'm showing you in terms of this presentation, everything will be doing the same on the system as well, right? And how we can get this particular ADT, right? So let's say you started working on it and you want to download this ADT, right? So you can do the download in the download center, right? And once you download, you need to do few steps in order to configure the relevant libraries or the tools. I'll again show you how to configure it once we get hold of the system. And it's pretty straightforward. We just use these URLs. after you download the ADT, we use few URLs to configure it. And once they are installed on the Eclipse, you should be ready to go with your development. Right? Okay, that's all for this particular topic ADT. Any questions on this ADT?
Durga, so only Eclipse supported this, is it?
So also I did not get your question. What was it, sir?
Only Eclipse, like only Java programming we can do it, is it?
No. I think you got it wrong. So what I have mentioned is, let's go. SAP has taken the base platform of Eclipse, and top of it, they have built this particular ADT, which is used by the SAP developers. You can do everything. So as I said in the screenshot, right, you can create packages, you can create functional modules, you can create ABAP programs. Along with that, if you have any non-ABAP related development, if you want to do, you can do that one as well inside this ADT.
Yeah, so only Java development, is it?
Not Java. So whatever the default perspectives, this particular Eclipse support, everything is along with this ABAP development.
Okay, fine. Generally, Eclipse support the Java programming, right? So that's why.
Yes, Eclipse supports Java, JE, right? We create so many projects inside. Similarly, the base functions remains the same, but they have put in an extra ABAP support feature on top of it. That's it. There is no change in the base features. Are we good?
Yeah, hi. Can you please share that links in the chat window for downloading them?
This one is it? I think okay. I can put it. This is okay. Let me try to put it.
Sure. Thank you.
Anyways, if you just what you call Google also, this ones will change because now it is not supported SAP.com, right? It's open support launchpad. So what you can do is you can go to the downloads and you can get it. But if you want, I can try to provide as well. I'll just try to see if I have the URLs handy.
Sure. Thank you.
Right. Okay. Now let's move to other topic. Okay, that's just give me some space. So now we'll jump to the next module, right? So this is also an important topic what we'll be discussing, right? Oops, I think I missed the first part. Just give me a second. Can you see my screen?
Yes.
Can you spell out what is the text you are seeing? Are you seeing this SAP HANA secondary database slide?
Yeah.
Oh, good.
SAP HANA secondary database.
Okay, good. So this is the second module what we'll be talking about. So we saw the basics of HANA server. We saw what are the different tools we need and what are the different benefits we get, right? So now we'll talk about the database part, right? Yesterday, if you remember, I tried to bring in this particular point in one of our discussion, like HANA, how in the evolution of HANA, how they have brought it, right? So they initially brought it as a secondary database, and slowly they pushed it to HANA as a primary database. That's how the HANA has evolved, right? So we'll talk about that particular point. So what is this necessity to install HANA as a secondary database, right? So what is the necessity to install HANA as a secondary database, right? So if you're following this particular architecture, right? So what happens is we are already having our primary database, which is Oracle or MS SQL or MaxDB. Along with that, we have added a new database, which is HANA, and we have configured it to work as a secondary database. Right? So why we generally do that, or what is the necessity, right? So let's say we have few programs or reports, right, which is taking a humongous amount of execution time when we're trying it on a primary database, right? We have done a lot of analysis around it, and we came to a conclusion that our system is very stable, and whatever the objects we have built are pretty much optimized and they are working fine. But we don't want to run all our other reports, transactions on it, because we are not seeing any improvements. So what we can do is we can try to run those programs or reports, right, to run on SAP HANA database, which we have just gotten as a secondary database, as they are taking too much of time even after performing all sorts of the performance improvement techniques on top of it. Right? So this generally happens because of the limitation of the non-SAP HANA database, right? As we all know, SAP HANA deployment empowers a business with speed. The main selling point of SAP HANA database is its speed, because SAP claims that the speed is approximately 3,600 times faster than the traditional database while it is doing the calculations or when it is doing the transactions. That's the key selling point of SAP in terms of SAP HANA database. So if we want to accelerate all these programs or transactions, which is taking more time for execution in the traditional database, one of the option we can think or to make it work efficiently is to go and try it to run it on our secondary database, which is HANA. Right? That's what the necessity is. So let's see how does this particular work, right? Now simply we'll take a simple report. Let's say we have a report A, right? Or let's say we have a report which actually displays all the sales orders for a particular set of customers in a region, right? So that report is very slow, and we are thinking of ways how we can make it to execute quickly, right? As we discussed earlier, we have done all sorts of analysis, and we came to a conclusion that we have done 100% in terms of optimization of the report. We can't do anything. We have improved the hardware of the servers, but nothing is going around, right? So we need to think of an alternative way. So what we have to think is, we need to identify all the database tables used in that report, right? Once we identify all those database tables, now we got to know, or we got to know that there are around, say, 5 to 8 database tables. Let's say 8. We have 8 data tables which are being used inside that particular report, right? So all those 8 data tables which we have identified in that particular report are available in the primary database, right? And also the relevant data inside the tables are also stored in the primary database, right? So the data of these 8 database tables, what we have been using inside this particular report, now what we'll try to do is, we'll try to replicate the exact data from our primary database to the SAP HANA database using the SLT. Right? Somehow we push the data from our primary database to a secondary database. SLT is nothing but a real-time data replication tool which we use, right? Let's say we have pushed the data from the primary database to the secondary database. So once the data is residing inside the HANA database table, right, the reports which are running on the primary database can read data directly from the HANA database instead of the primary database, right? This is how it works. So let's say you have done all this part, and now if you want to try to run this report, so what we'll do is, instead of going to the primary database, we ask the report to connect to secondary database, which is our HANA system, and try to execute it. Right? How can we achieve this? Okay, we are saying that we need to tell the report to go there, but how can we achieve this? Right? So this can be done with the help of setting up a secondary database connection. So this is more of a basis related stuff. We will not be doing it, but I just want you guys to understand the concept of how this secondary database connections work. So this can be done with the help of a concept called the secondary database connection, right? So the connection from the primary database to a secondary database is established using a T code called DBA cockpit. That's the T code which we use if you want to set up a connection from the primary database to the secondary database, right? So there will be a slight change in the select queries of the reports, right? In order to reading the data, right? And we also need to do a few changes in adding a connection as well, right? But the rest of the things remain same. So each application server ABAP is connected to the DBMS that contains ABAP depository, right? So whatever the primary database, what we have, you take anything, MS SQL, Oracle, or anything, it does not matter to us. So once we brought in SAP HANA as a secondary database and you have set up a connection using the transaction code DBA cockpit, right? Your system should be good to run that report on top of your secondary database, which is HANA. So each database connection is identified by a name which must be unique within the application server, right? It should not give the same name to a different set of connections. So this is how the screen of a DBA cockpit T code looks like. So if you go to this particular DBA cockpit T code, and if you click on this database connections, here you should see the connections. So here we have already created a connection called HANA DB. We have provided the DB host and the username. And if you click on test, you should be working fine. This is how a sidecar scenario system should look like. So if you go to a system where your HANA DB is a primary database, you will not see anything here because it's a single database. You can see some kind of entries in this particular T code and inside this database connection. So only if you're running on a sidecar scenario, right? And this can be used to access local or remote database systems, right? And all these settings, what we are trying to set up will be done inside the T code called DBA cockpit. Okay. It is simply a normal connection type, what we do, right? By giving the host name and the port and everything. Once this particular connection is set up and you have tested it successfully, and now what you can do is go back to your report. If you see here in the screenshot, I opened the same report, and here I am explicitly specifying the connection what I have created in my previous screenshot. Here you can see the connection name is HANA DB, right? So here inside the program, I am specifically or explicitly specifying that when trying to do a select query on these tables, instead of going to the primary by default, please go to the secondary connection which I have just created. And how can we tell to the program that go to the secondary connection? By using a keyword called connection and provide the connection name over there, which you have created in the DBA cockpit T code. Okay. Once you provide this particular connection, so once you run this program, right, what happens is based on the connection parameters, the query, the select query will now go and hit the HANA database instead of the primary database. That is what our intention is, right? So only tables and fields that are defined in the local ABAP dictionary can be accessed using this data packets connection. Okay. So in HANA, we have a few things called views and procedures. So we cannot access those objects using this secondary database connection, right? So only the tables inside the schema, which are assigned to the DB user, which we have used in the connection, can be used. So if you see here, we have used a username called repzme, right? So only the relevant objects which are assigned to this particular username can be accessed inside this particular programs. Only those tables can be assigned. right? Any questions? Good, good. So I also want to bring you one more point here, right? So in this particular, or once you set up a secondary database connection, right? So you can access that particular data via OpenSQL and also as native SQL, right? So the easiest solution for performing this SQL operation from ABAP to the secondary database connection is obviously by using the open SQL statements, like what we have saw here, by just using this connection keyword. And once it is connected, you should be able to access the relevant data, right? So the advantages of this open SQL is simplicity. It is pretty much straightforward. Just use the keyword, and we know how to write queries using ABAP language, right? So that's the reason why we mostly go for the open SQL, right? So, but we can also do the same thing via native SQL as well, right? So we can write the database-specific SQL statements, which allows us to connect to the secondary database using native SQL. But as you know, the native SQL is not straightforward. We need to write a lot of steps, like we need to write, say we need to open a connection first, like similarly what we do here. And we also write separate statements like exec SQL, which is the keyword to execute the statement. But here there is no need for you to write all the stuff. So the major disadvantage of using native SQL, right, via exec SQL, is that the statement contains significantly more code when you compare to the open SQL. That's one of the drawback what we have. So if you want to work using native SQL, we need to write a lot of code, right? So it's also less elegant to understand because it uses the database cursors concept. So that's not really fair, and it does not give you the essence of SAP HANA server. So that's why we generally go for using the OpenSQL only. Any questions? So the next topic what we'll talk about is what are the different code checks we need to do from a ABAP developer perspective when we are working on SAP HANA projects, right? So now the current trend, what is happening is most of the customers are migrating from their traditional ERP systems to SAP HANA systems. Either they're going to the sidecar or they're completely migrating from ERP to S4 HANA or SAP HANA. Both are one and the same in terms of migration, right? If they are just doing it from the DB perspective, right, whatever the task we'll be doing should be considering in terms of an ABAP code, right? What are the different considerations we need to take as an ABAP developer when we are working on this kind of migration projects, right? What are all the potential functional issues we may face and how we can try to solve them? So these are the different things we'll be talking about here. So what are the main considerations what we'll get, right, when you start working on this one, right? So let's say you are deployed into a new SAP migration project where your party is like a technical developer, right, or a technical analyst. So what is the first point it comes in mind? Because there is no need for us to worry about the standard programs, standard functional modules and all, because SAP takes care of it when we're doing this kind of a migration and moving it to HANA. The real problem comes to our mind is what happens to the existing custom code and the existing functionalities, right? Which of my ABAP code must be changed to avoid potential functional issues when migrating to SAP HANA, right? So if you just look at your report or a program, so we'll not be able to come to a conclusion whether this program will work when you migrate to HANA or not, right? We need to understand what must be changed or what must be corrected so that my program, custom program, goes and works in the migrated SAP HANA system. Right? Which of my ABAP code shall be optimized to ensure good performance? I wrote a report on traditional ERP system, everything is going good, that's fine. But if I move it to the new system, still can I optimize it further so that I can get a good performance out of it, right? Other consideration is which of my main business processes have potential for SAP HANA so that I can speed those up massively. We also need to identify different business processes where we can actually speed the execution time of those reports, what the business users are executing in their real time day-to-day jobs, right? When we are migrating to SAP HANA. And the final and important consideration is, okay, I got the points, like I need to identify all this stuff, but how can I find all this ABAP code easily and do the adoption efficiently, right? Yes, I understood that these are the things I need to consider, but how I can find which program is having issues? What are the different automation techniques I can use or tools I can use to achieve this particular considerations in reality, right? Let's see a few potential issues. Potential foremost thing what we need to consider is the native SQL statements. So we need to check if the native SQL uses vendor specific statements, right? Vendor specific statements means, so when you say native SQL, it's like if you use Oracle, it will be, the statements will be different when trying to connect and access the database. When you use MS SQL, the pattern of statements or the keywords what you use is different, right? So that's one of the disadvantage of using a native SQL. Those are vendor specific. And if you are using those native specific statements inside your reports, first we need to identify in which reports we are using them and how we can replace them by the open SQL statements or by the native SAP HANA constructs, right? These are two other different things what we can do. We also need to check if previously used hints are still needed or not, because we will have the concepts of hints, right? So we also need to check if those particular hints are needed or not. If not needed, you can just remove it. Okay, those are also different things we need to check as well. Right, so these are like our database hints. So we'll not be talking much about this one because these are just like to provide some hints to specify at the database level, right? We generally use this kind of percentage for hints after the select statements or the where conditions, right? These are the few potential function issues what we can check or what we need to check, right? And if you recall yesterday's session, we also discussed that there is no concept of pool or cluster tables, right? There is no concept of pool or cluster tables in SAP HANA DB, right? So we need to check if there is any direct access to physical pool or cluster tables as well. And we also need to check the existence of secondary indices, because with the introduction of SAP HANA DB, they have completely removed the concept of the secondary indexes, right? And we also need to check if we are relying on the implicit sorting, which we generally do it on top of the pool or cluster tables, right? So these are the few potential functional issues what we can consider when trying to work on a migration project, right? So we use two tools, right? So these two are the important tools which we use when we start working on this particular migration project. Okay, so these two are the two important tools what we generally use when you start working on a migration project, right? So what are these tools, right? Let's talk about these tools first, right? What are these tools and how I can use it, right? So as we know, we'll be having lots and lots of custom code which is written by so many developers right, to achieve various business requirements, right? How can we guarantee that everything will work once the migration is completed, right? To check or to get a clarity or to get the confidence on that particular part, SAP has provided us with two tools, right? And this is not a tool, this is not a new tool which is provided by SAP on top of HANA. These tools are existing from many years, but we started using mostly when we are doing this kind of a migration project. Okay, so these tools or these two tools helps us or supports us to plan and decide that our move to HANA database is smooth by ensuring that none of the cases, like the failed cases, like database issues, native SQLs, all those things will not happen to our custom codes, and the functionalities will not break once the migration is complete, right? So what are these tools? The first tool we called it as a SAP Code Inspector or SCI. We call the first tool as SAP Code Inspector or SCI. And the second tool what we have is the ABAP Test Cockpit, this ATC, ABAP Test Cockpit. So why there are two tools, right? Because SAP has provided two tools. So is it not, or one tool is not sufficient? Definitely we need to use both the tools, right? That will be the question which comes into your mind. So both these tools does the same job, right? Does the same job, but the USP is different. USP of the each tool is different, right? So what we'll try to do is we'll try to do a scenario using both this Code Inspector and ABAP Test Cockpit. Then you'll understand how these two tools will behave. Okay. And then we'll talk about what are the disadvantages we have when using ATC or SCA. Okay. So this is a screenshot what I have put in, right? So we'll have few important variants which we need to use, right, when you are trying to do this or use this Code Inspector or ABAP Test Cockpit. So you can see the screenshot here. The functional variant, sorry, the check variant what I have used is function_db, right? And once I execute this particular variant and I can see different set of values which I got, right? And I can see all this stuff. So what this particular Code Inspector checks, right? So it mainly checks for the critical statement. So it searches for the DB hints and the native SQL statements. So if it finds any what you call the DB hints and the native SQL statements, it gives us back with a error message that, hey, this is a critical statement, what you need to fix, unless you cannot move forward, right? Those we call it as a critical statements, right? The use of ADBC interface. So I'll not talk about ADBCs much. I'll just skip this particular point. We'll talk about ADBC when the time comes. Okay. It also searches for the DB operations in the pool or cluster tables. Because on top of SAP HANA, we know that these pool or cluster tables does not exist, right? So it searches for the direct access to those pool tables and table clusters, and it gives us the result back. We need to do the necessary corrections to it or the necessary adjustments to those kind of tables. It also searches the problematic statements for the result of select or open cursor without order by, right? Along with the critical statement, it also checks for the optimization part as well. So if there are no state, if let's say you wrote a select statement and if you did not write any order by, right, it gives us that as a result back, right? It says that you need to follow few database performance rules in order to improve your report performance on top of HANA. So these are the different suggestions it's provides us back, and once we correct all those things, we should, or we can confidently say that yes, my custom report which I have built will definitely go and work on top of SAP HANA once it is migrated. That's the confidence this tool gives us, right? So yeah, this is also arbitrary patterns what we have. So if we have this kind of function doing this, right? So all these things we can just find it out. So once you execute it, right? So once you execute that SCI, right? This is the result, or this is how the result looks like. So here it is clearly saying that, right? It is providing you with a few statements. It has got a statement where you did not use a order by after the select. So it will tell you that go back to this particular line, do the necessary adjustments, and you should be good to go. These are the different kind of suggestions this particular tool provides. Any questions? Right. So now we'll talk about the tools which we use to analyze the performance issues, right? So how these particular tools helps us in identifying these performance issues, right? So it gives us, or what is the reason for the performance issue, and what are the tools we use to measure and compare the runtime consumptions, and how we can search for potential performance issues using the two tools which we discussed earlier, which is Code Inspector and ABAP Task Cockpit. And we also use a SQL trace code ST05 to do the in-depth analysis of the database accesses. These are the topics what we'll be covering in this particular presentation. Right? So the tool what we need is how the performance of the existing ABAP code will perform after the migration is completed, right? So some code may immediately, or some, when I say code, it may be a report or a program or a functional module, right? Some code immediately runs faster, right? Some code might be negatively impacted and we should be revisited that particular code, right? We are not so sure how it happens. We have done the necessary migrations and improvements, but we are not so sure how this particular thing will work, right? So we can do this runtime analysis by doing a ABAP trace. So we can put a trace for the program and we can try to measure, right, based on that measure. So how many or how much of time your open SQL statements are taking, and if you have any statements in terms of native SQL, right, we can also get a trace of that as well using the ABAP trace. We call that as a runtime analysis, what we do inside the workbench, right? So what are the different characteristics we have, or what do using the ABAP runtime analysis and the trace? The functions of the classic ABAP runtime analysis, which we do in the SE30T code, right? If we want to do a ABAP runtime analysis, we go to the T code SE30. And we have a new tool called SAT, right, which takes the ABAP trace, which can be completely used in the SAP HANA context. So SAT is a good tool, what we can use if you want to get the ABAP trace. So both the tools function one and the same. They measure the runtime of the processing blocks. So once you run a report or a program, it clearly tells you which method took how much amount of time, which function took how much of a time, or it also provides a execution for a single statement as well. So based on that, we can identify the bottleneck of which statement is taking much execution time and is totally or impacting the overall performance of the report or a program, right? So this is what a runtime analysis we can see in the ADT itself. There is no need for you to go again outside. So you can see this runtime analysis in the ABAP Development Tools itself. Right. So once we do the performance checks inside the Code Inspector and ABAP Task Cockpit, that means we have set the problematic select start statements. We have also identified the loops across different modules or subroutines, and we also had search for all interest clauses to be transformed. So these things we need to do just to improve the performance aspects in terms of the identified custom code, right? So these are all the different things what we'll be doing, right? Good. So I'll show you by sample programs, right? So I'll try to showcase you the difference, how it will push us back when we use those select star statements, and if we use few keywords which we should not use, and how we can correct them once the system tells us this is what you need to correct. So we can just see everything using sample programs on the live system, right? So this is the in-depth analysis of the performance issues, right? So if you go to the ST05 T code, you can clearly see which object, which statement has taken how much amount of processing time. So it generally, this particular T code displays the record of all database accesses, right? If you have a sidecar scenario in your landscape, so it also includes those SQL calls as well in this particular transaction code ST05, right? So once we have a look at this particular report, we can easily identify which select statement is eating more amount of time. Based on that, we can revisit that particular statement and do the necessary optimizing steps on top of it, right? So it displays all this database execution step plan for all the statements. This is a good T code what we can use when you are doing some analysis on top of a report or a program in terms of the performance issues. What are the different uses of this SQL trace ST05? So ST05 is a T code which you need to execute in the GUI or the ADT if you want to do a SQL trace. So it actually displays us the record of all the database accesses. It provides us the list of activities or the select statements or the database activities which are involved in that particular report or a program, right? It easily detects those identical select statements, and it provides a simple list like this particular select star statement has took this amount of time, right? Based on that, we can take our call and we can start fixing those statements so that they are optimized, right? Yeah, this is how we generally do a performance trace. So go to ST05, right? Execute the trace. You want SQL trace, right? Just select that SQL trace, and you can activate trace with filter, because what happens is if you are now trying to run a report, if you put this activate trace, if let's say if you are trying to put this trace on a production system just to identify the real-time performance of a report, right? So how many users are, let's say 100 plus users are logged into your production system. So the trace of all those 100 plus users will be taken into consideration. Just to eradicate that, if you use the option called activate trace with filter, it will ask you for the username for which you want the trace. So in that case, just provide the username of the user who is actually running to run that particular report or program for which you are trying to get a trace of it, right? First click on this and run the report. All the entries will be captured. Come back to this T code, click on the deactivate trace, and then click on the display trace. Then you should be able to see all the select traces, whatever or what are being used inside that particular custom report or a program. But this is how we generally take the performance trace using the ST05 T code, right? This is something called an execution plan. We will not use much. This is more kind of an database related activity. So I will not touch base this one. Okay. Any questions in terms of SCI or ABAP test cockpit or the performance improvement ST05 codes?
Can you repeat the sequence of activating trace with filter,
okay.
And then you said something like deactivate trace and
right.
then display trace.
Right. So let's say you have identified a report, and that report is being executed by one user. Okay. So the first and foremost thing what you need to do is come to this particular ST05T code, and you will see this particular screen, right? The first and foremost thing what you need to select is the trace type. What type of trace you want to do, right? Select this SQL trace because we are focusing more on the database related performance. So we have selected SQL trace. Select this SQL trace, click on activate trace with filter. Once you click on this activate trace with filter, it will ask you to provide a username. So username is the one who actually runs the report for which we are trying to take a trace, right? Let's say Joseph. Joseph is the person who is actually trying to run the report for which we want to trace. So we will, before Joseph runs the report, we will enter the Joseph's username by clicking this button, activate trace with filter, and provide the Joseph name inside this username details and say execute, right? That's the first step. Once that is done, we'll go back to the Joseph and ask him to run the report, right? Once Joseph executes, completing the report, once he confirms that the report is completely executed, we come back to this particular ST05, click on the deactivate trace button. Once you click on the deactivate trace button, the display trace will be enabled. Then click on the display trace to see the trace entries.
Okay. Okay. I got the process now. Yeah.
Okay.
Thank you.
No problem. Any more questions? Good. So we'll jump to the next topic. You should be seeing the slide now, guided performance analysis. Are you able to see it?
Yes.
Good. So we'll be touch basing two other tools. You can call this two other tools which we use when working on this kind of performance improvements or performance analysis, right? These two are also important tools. The first one is SQLM. That's a T code what we use. So this is to understand the SQL monitoring part. And the second T code or tool what we use is SWLT. This is a performance tuning worklist T code. So these are the two other tools which we can use when you are trying to do the optimization in terms of performance, right? What are the different steps we use, right? So the first and foremost step we use in terms of the performance optimization is we do a static code check. So what is a static code check? It is to identify the location of the known critical code issues. That maybe the select by star, you don't use any order by, all the stuff. So what is the tool which we use to do this particular static code checks? We can either use SAP Code Inspector SCI, or we can use ABAP Test Cockpit. We can use any of the tool to do the static code checks. And in which system we need to do this code check? We need to do this particular code check, or we need to execute this tool in the development system. That's the important point which we need to remember. The second step is, once we are done with the static code checks, the second step is we need to get the runtime information out of the production system, right? So we need to understand what are the programs which are being mostly used by the customers on the live production system, and also what are the different programs and reports which are being mostly used, right? Until and unless we identify those aspects, right? So let's say we have around 1,000+ objects in the live system, and you just can't go and dump all those 1,000+ objects and start doing performance optimizations, right? So we need to make a plan. So how we'll prepare a plan? We go to the live system, right? we try to get the runtime information out of this production system, like mostly use reports, mostly active programs. We get the top list, let's say top 100 or so, the most important and the critical ones for the business to run, right? We get those lists. So how can we get that particular list? Using the tool called SQL Monitor, right? So that's why we should run this SQL Monitor in the production system, right? This tool mainly helps us to monitor the most expensive SQL statements in your production system. Okay? This tool helps us to monitor the most expensive SQL statements in the production system. Once we understand, right? Once we understand this particular data, or once we have the data, like how much execution time this particular programs is taking and all, what we do is we generally we have what you call a technical word called snapshot. We take a snapshot of that particular output, and then we'll export it, and then we'll import that particular snapshot into the development to start our analysis. And where we or once we get that SQL monitor snapshot, we need to go to the next list just to prioritize, right? We use a tool called SWLT, SQL Performance Tuning Worklist. Okay, this is what a SWLT is. So, what are the prerequisites we should need in order for you to run this SWLT? Is we must have run the SQL Monitor in the production system, and we have created a snapshot out of the data, right? As I said earlier, we'll export that particular snapshot and import it in the development system. And inside the development system, the second step is we configure and run the ABAP Task Cockpit ATC or the code inspector on top of it, right? What this particular SWLT does is it combines, right? It combines the results of static code checks which we got from the ATC, and also the results which we got from the SQL Monitor, right? Got my point? So it combines both these results, and then it gives us the report like these are all the what we call these are all the mostly affected or used programs, right? Which are being affected in terms of performance. And we can just start focusing on those particular programs and the statements, and then do the necessary corrections. This is the step-by-step guide what we can follow when you want to do a performance optimization, right? The first step, the static code checks, will be doing it on the system. The SQL Monitor will do it on the production system, right? And we'll combine these two, 1 and 2, static code checks and the runtime information which we got from production system inside the SWLT tool to prioritize the work list, and then based on that to do the optimization, right? This is how the SQLM looks like, right? So once you execute all this, right? So if you see here, the execution time is more. So this is like this particular program is eating a lot of DB space, and also it is taking too much of time, execution time, right? So these are the different findings what we can get when we run this SQLM Monitor in the production system, right? Good. So they have brought in few things which they call it as a new ABAP SQL Monitor. It's almost one and the same. So instead of this monitor transactions, right? So they read the data from the database tables. So they just keep on monitoring the data which is being moved here and there via the batch jobs which are specific to those database tables. So these are the important three things what we should do when you are trying to focus on the performance optimization. To go and use the SCI or ABAP test cockpit, to use the SQL monitor, and then to use the SWLB, right? So how can we switch on this SQL monitor? Because we are doing, just to remember, right? So we are doing this SQL monitor on top of a production system. So once you are set to take the snapshot, then only you need to go to this T code SQLM, right? And switch on this monitor. And once everything is done, then you can simply switch off it. That's what we do. And I will also show you how to take the snapshot, how to export it, how to import it, development, everything on the system in the coming sessions, right? And you can also see the SQL monitor data, whatever you got. Either you can go to a separate code called SQLMD, or directly we can navigate inside this SQLM only and to see the data. So I can show you those two things as well, right? So as I said earlier, once you got the snapshot, right? Once we get the snapshot, which is saved on the production system, we'll export the snapshot which we got in the production system and import that particular snapshot into the development system to start our analysis. Right? We can, what they have done here is SWLT. Sorry, I think the code is wrong. SWLT. So here it does the SQL monitoring. It analyzes the SQL profiles, right, to identify which business processes should be optimized. Along with that, with the help of ABAP test cockpit results, we also identify what ABAP code should be optimized, right? So the SWLT allows us to correlate the SQL runtime data with the ABAP code analysis and to plan for the final optimization. We combine these two inside this SWLT to prepare a plan for the optimization. Once you execute this SWLT, right, this is how it looks like. So you'll get a list, right? It gives us a list like these are the top. So if you see here, there are different request entry points. If you click on any of the record, right, once you filtered it based on the execution time, if you select any of the record, at the bottom, you can see the SQL monitor result, right? What are the different entry points? What are the different methods? What is the class which has used? Everything you can see. To the right side, you can also see the ATC check results. So ATC check results are more specific to a statement, like select star, order by, usage of native SQL statements. All those things will be, from a code perspective, will be shown in the ATC checks, right? Any questions? This is an important topic because when you are working on a migration project, this one you should definitely need to consider. Or people will ask you to provide the plan for this kind of activities in the migration projects.
Yeah, if you can stay on the same slide. So what I understood from this slide is that the first one, static code check, needs to be done in the development environment, and the SQL monitor trace, SQL monitor needs to be done in production. So I have the result from the code inspector from development. I have SQL monitor result, and what should I do? The next one. I mean, compare these two, because anyway, because development and production will be different, right?
No. So, okay. So you are not comparing at a code level. So the first one does a code check. The second one, the SQL monitor, actually gives you the mostly used reports on the program names. If you see here, it gives you the fully used or the reports which are taking too much of time from a database level. It does not do the code checks. It just gives you the full report of the database interactions.
Okay.
The SCI will give us the issues or locations where we have problems in terms of code statements.
That is step number one.
Number one, yes.
Okay.
And then we try to combine these two to finally get a single screen where we can do these corrections.
Okay. Okay.
Just make a note of it. Anyways, we'll be doing a couple of examples on SCI, and then we'll try to take the snapshot. We'll do each and everything. So we should be good.
Okay.
You just understand the concepts.
Go ahead.
Yeah, just try to understand the concepts. And when we start working on the system, then you try to correlate. I think then you'll get a better picture if you have a little bit of confusion over here.
Right, right. So is there a T code for static code check?
Yes, this is the T code. The tool, whatever you're calling it as a tool, right? It's like ATC. It's a T code ATC. We have another T code called SCI. SAP Code Inspector. Those are the T codes here. We just call it as tool, but those are T codes.
ATC and SCI.
SCI, yeah.
Oh, okay.
Anyways, we'll run it on the system, so I'll show you more clearly when I'm doing it on the system.
Okay. Thank you.
So these tools are inbuilt, right?
That's right. Yes, inbuilt.
Okay.
Good, guys. Then that's all for today's session.
Thank you for attending the session. I hope you all enjoyed it. Don't forget to like and subscribe to our channel. Also, feel free to ask your questions in the comment section below, and we will reply to them at the earliest.